Alrighty, so before I begin, I want everyone to close your eyes. Please close your eyes, keep them closed. Now imagine you lost your sense of sight, your sense of vision. What would that mean? Well, for one, you wouldn't be able to see the slides that I'm about to present. You also probably wouldn't be driving anymore since you can't see the road. But most importantly, you wouldn't be able to see the faces of your loved ones. Let that sink in. All right, go ahead and open your eyes. Good morning, my name is Blaise Pasquale, and today I'll be presenting on bionic eyes. Specifically focusing on how these systems are used to restore vision for blind patients and provide artificial sight for humanoid robots. Let's get started. So our agenda for today, we'll be covering the following: a brief orientation into the world of bionic eyes, an overview of the general structure and function of these systems. Then we'll dive into three critical components: the sensors, the actuators, and the signal processing and control mechanisms that tie everything together. Lastly, we'll discuss challenges and future direction of this industry. But before we begin, allow me to draw your attention to the floating eyeball in the center of the screen. This animation highlights some of the complex biological machinery that is the eye. Features that need to be replicated in bionic eyes. The eye can rotate and the pupil can dilate to control the amount of light that enters the eye. This just scrapes the surface of what the human eye does. So for a quick orientation, in the top left, there's a headline from IEEE Spectrum, kind of a journal, news journal for the IEEE. We kind of touched on that a little bit in class, but a new bionic eye, infrared light-powered retina implant coming. So that was in 2015. This is when the Second Sight's Argus 2 model was going to be starting to be implanted into humans. But 2022, next headline, their bionic eyes are now obsolete and unsupported. What happened between 2015 and 2022 was that roughly 350 patients were getting the Argus 2 implant in their eye, but because of bad business practices, the company was starting to go under. And this kind of highlights the importance of having a good business, having a good market, validating that market, because even if you have the best technology, if there's no viable business, you might be doing more harm in the long run than good, because now people will have this thing in their eye that they're not going to be receiving updates for. They're not going to be able to, like, if something goes wrong in the future, who's going to be able to take care of it if there's no staff that is trained to help fix these things? So it's really important to make sure that you balance that technology with good business practices. But fortunately, earlier this year, we got another headline that says Bionic Eye gets a new lease on life. So there's still hope for this company, and I have some more news that I'll share at the end. Some exciting stuff in the Bionic Eye industry. So what exactly is a bionic eye? In simple terms, it's an advanced system that enables artificial vision for individuals who have lost their sight due to retinal diseases like retinitis pigmentosa or age-related macular degeneration. It aims to restore vision by bypassing damaged photoreceptors in the retina and sending visual signals directly to the brain. For humanoid robots, on the other hand, the goal is not to restore, but to enable artificial vision, helping robots navigate and interact with their surroundings. Both use similar core technologies, but they differ in their specific applications. So let's break down the basic structure. This is the Argus 1, which is the predecessor for the Argus 2. The Argus 2 was the only American bionic eye that had FDA approval. So that's kind of the main one that I focus on, but there's a lot of trouble that I had finding the specifications. There's a bunch of other competing companies. So I may be picking and choosing from some of the other potential solutions that are out there. So The main sensor is the camera, and the top left you can see number 1. The camera captures that image and sends information to the microprocessor. The microprocessor converts that data to an electric signal and transmits it to a receiver. That receiver then sends the signal through a tiny cable to an electric panel implanted by doctors on the back of the eye. Then, if you go to the top right, retinal implant emits pulses which travel through the optic nerve to the brain. And lastly, the brain perceives patterns of light and dark, which correspond to the electrodes stimulated on the retinal implant. So you can see that these are kind of like, I guess a comparison is pixels. So the vision isn't perfect. You're limited by the amount of electrodes that are actually able to be implanted. And we'll see that that is like the main limitation of the system. Is how many electrodes can you get, shove it in your freaking eye, and create vision. So starting with the sensors, for both human bionic eyes and humanoid robots, the primary sensor is the camera, often mounted on glasses for human patients. It works much like the photoreceptors in a real eye, converting light to electrical signals with the help of the video processing unit. In humanoid robots, on this right side, there's an additional component, an IMU, also known as the Inertial Measurement Unit. These sensors include accelerometers and gyroscopes, helping the system detect head and eye movement, which assist in gaze tracking and adjusting the visual data input accordingly. IMUs are particularly important for robots as they help with balance, orientation, and movement control. Now let's move on to actuators. The actuators are responsible for inducing the sensation of vision. For human patients, this usually takes the form of electrode arrays, implanted in the retina or even directly into the visual cortex of the brain. These arrays they stimulate functional neurons using electrical pulses, allowing the patient to perceive light and shapes. So that's kind of something to emphasize. If someone is born blind and they don't actually have any functional neurons in the retina, this technology would not work for them. This is for people that have kind of gained blindness, so to speak, that maybe they still have a few neurons in the retina that are working. So this is the Argus 2 system, relies on stimulating those neurons that are still working. And in humanoid robots, there's some additional actuators. They are used to simulate eye movement and adjust gaze direction, mimicking natural human eye motion. This enables robots to look around and focus on objects in their environment. So this kind of shows that we have like a driving stator, we have the eyeball, and there are all these different actuators that will help rotate the eye. And one of the cool things that I found is this type of system for the humanoid robot use case is used by companies like Disney to make their kind of realistic characters. So I wouldn't have thought that you could be like a robotics person and work for Disney. So that's really cool. Now, let's talk about the signal processing and control system, which acts as the brain, so to speak, of the bionic eye. In human systems, a microcontroller processes the data from the camera sensor and then converts it into electrical signals that can simulate neurons. In robots, this is typically a more complex computational system that not only processes visual data, but also interprets it using algorithms for tasks like object recognition, motion tracking, and decision making. In both cases, wireless transmitters play a critical role, sending data from the camera to the microcontroller. For humans, this data is then translated into visual information that the brain can understand. This picture is of Second Sight Cortigen's latest bionic eye system called Orion. There's more electrodes compared to the Argus 2, which was the one that was most widely used in America. And it's still kind of clunky and bulky, but previously the video processing unit was like attached directly to the glasses, and it was like very uncomfortable for patients to use for extended periods of time. But because of wireless transmitters, you can like they don't have to be co-located anymore. You can have the video processing unit in like a pocket. So that just shows the user experience is something that they were working to improve. And part of the reason why they were starting to go bankrupt earlier was because of little things like that, those little comfort constraints. So while the technology is groundbreaking, it's important to acknowledge the challenges. For human patients, the main limitation is the resolution of the electrode arrays. And then over on the left side, that is an actual picture of inside of the eyeball and how it's connected into the retina. So you can see that there's, like, you can visibly see that the electrodes are those little pixels. It's not as condensed as what would enable better vision, better sight. So that is like the main limitation is how many electrodes can you stuff into the retina? The Argus 2 only has 60 electrodes, which means the vision it produces is quite basic. Patients can see light and motion, but not clear details. And just kind of earlier last week, the Bionic Eye industry itself has seen some pretty crazy news. So I shared Elon Musk's tweet. His company Neuralink just announced their blind sight device, which claims to restore vision even in patients who have lost their optic nerve. So this was like last week, like writing up the report, trying to figure out like some details. What is like the cutting edge of bionic eye technology? And this came out, and this kind of innovation signals exciting potential for future breakthroughs. And one of the best things about Neuralink is that they created this full stack of engineering brain-computer interfaces, which is similar technology to what is required for the Bionic Eye. Their Neuralink device has so many, I don't know the exact number, but it has a lot more electrodes that simulate neurons in the brain compared to something like the Argus 2. So because of that, there's a higher resolution, there's more density of electrodes, so the signal is refined. To conclude, bionic eyes represent one of the most exciting intersections of biology, technology, and engineering. Whether restoring vision for the blind or enabling humanoid robots to see, the potential applications are vast. But as we've seen, the challenges, both technological and financial, are significant. Yet with ongoing research and innovation, the future of bionic eye technology looks incredibly promising. This is a picture of a video GIF of Robert Scoble, who has a bionic eye implanted in like his own form of a bionic eye in his head. He put it in there himself, actually. It's not connected to his retina, but he is actually a filmmaker, and he records videos with his so to speak, bionic eye. So
it's like POV, that's pretty cool.
yeah. Thank you for your time. I'm happy to take any questions you may have.
Yes, let's send a call.